we live in an age of technological marvels where it sort of feels like we've solved, lots of humanity's problems.
Yeah, both physically and biologically, okay? We've got medical breakthroughs as well, like smallpox, never heard of it. I mean, I have, but I've never got it, and I probably won't ever get it. You know what I do still get? All of us still get? A case of the Z's. Every day.
Yeah.
Every day I get tired, I have to close my eyes and do nothing productive for 8 hours.
It is such a waste of time. A third of your life, Michael.
Hello, science. Can we fix this?
Get on it, please. We're not asking today. We're demanding.
We're demanding answers. We're demanding solutions. Why haven't we cured sleep? Or I guess to be more fair, why haven't we removed our need for sleep?
Right. I think we can all agree that sleep feels like a design flaw. It's like, I want to be maximally productive. This is not the way I want to do it.
Yeah, it feels like a design flaw when looked at from a certain angle, not only because it's unproductive, but it's also dangerous. Okay, imagine that we're prehistoric people. We sleep on the ground. Hello, we've got predators. We've even got conflicts amongst ourselves with people in our group, people outside of our group. We're just sitting ducks there.
Yeah.
Like, how does it make any sense? Wouldn't it be better if we were just always on? This episode is brought to you by Cancer Research UK.
The word cancer comes from the Greek karkanos, meaning crab, and Hippocrates used that word because tumours can spread out like crab's legs.
For a long time, cancer was poorly understood, and so I think because of that, it was almost scarier, and people didn't even say its name. But what science has done since is replace uncertainty with understanding.
But that understanding isn't instant, because cancer isn't just one disease. It's hundreds of different diseases, each behaving differently depending on where it is and its genes. And that complexity is why progress in cancer research can feel like it's slow. But step by step, research is saving and improving lives.
Now, that's why Cancer Research UK, the world's largest charitable funder of cancer research, supports work across more than 200 types of cancer, from the tiny changes inside cells that start the disease to better ways to spot it earlier and treat it more precisely.
For more information about Cancer Research UK, their research and breakthroughs, and how you can support them, visit cancerresearchuk.org/the rest is science. I mean, people have tried this, right? So famously, there was quite widespread use of amphetamines in World War II. I think that was... The Nazis didn't do a lot of good stuff. I think I'll just end that sentence there, actually.
You don't need to elaborate, but they did bad things to themselves, too. I mean, you've seen the video of Adolf at the Olympics or whatever, and he's just shaking.
It was quite a successful strategy to turn German soldiers into basically machines. I mean, one of the reasons why Blitzkrieg was so successful was exactly this idea that you were not limited by the sort of biological bounds of the human body if you can drug your way out of it. But it only works for a very short period of time. I mean, you can't cheat sleep indefinitely. You
cannot. It comes back and it bites you, and you're much worse off. There are a lot of hacks. There are a lot of strategies to do, shorter naps throughout the day, like a very segmented kind of sleep schedule. And maybe then you still feel refreshed and sharp, but you've only slept fewer hours. But this is all centering around two things, basically. People who have sleep disorders, they're uncomfortable with how they sleep. They can't get the rest that they need, or they don't want to have to sacrifice so much of their life to sleep. And so I want to go through and just put this sacrifice in perspective. Humans sleep about a third of each day, about 8 hours. Okay, which means that when you live to the ripe old age of, say, 80, you haven't. 53 and a third years is all you get of waking life, even if you get to live to 80. Okay? It gets worse when you look at other animals, like a cat. Let's say you had a cat that lived to be 20. That's pretty good. That's an old cat. But yet that cat really only lived to be 13, because they spend how much? I wrote it down somewhere.
35%.
Okay, 35% is a lot. Humans, adult humans, only spend about a third of their lives sleeping. Cats spend a little bit more than that. But the little brown bat spends 83% of its life sleeping.
I mean, what is the point? It's not getting anything done.
It's not getting anything done. And I think that's actually a really deep way to put it, because this bat, it sleeps in caves all the time, and it gets up for 4 hours a day to eat, because its food source, which is like mosquitoes and like insects that are only active also in a short period of time, it's only available then. If it stayed up later, it would get too cold at night and it wouldn't be able to keep itself warm. If it was up during the day, it would get eaten by predators. So it's got this very thin, liminal evening window to eat food and then go back to bed. When you spend more than half of your life sleeping, it's almost this trippy inversion where you exist to sleep. You are a sleeping creature, and you just wake up long enough to eat enough that you can keep sleeping more. That's your purpose in life, to be asleep. So there's so many animals whose entire purpose on this planet seems to be to sleep. But let's go up this chart. Pythons, okay? I'm not going to just focus on mammals. Pythons sleep 75% of their life, 18 hours a day.
Lazy.
And here's my favorite, the mouse. The
Okay.
mouse is the ultimate liminal creature. It spends almost exactly half of its life awake and the other half asleep. Horses, other side of the spectrum, only 12% of their life is spent sleeping, about 3 hours a day.
Wow.
But the ruling, complicated big animal for not sleeping is the wild African elephant. It only sleeps about 9% of the time. So that's only about 2 hours a day. That's it. But here's the thing, I want to throw this in there, and I think we'll revisit it later. If you capture an African elephant, it will sleep 20% of the time. So it goes from 2 hours to 4 to 5 hours a day. They start sleeping more if you capture them.
I mean, it's just way more boring. Way more boring.
It's way more boring. And I can tell you the other hypothesis is that they just don't need to eat as often, because their food is being given to them. It might even be higher energy food. And so their body is like, well, we can rest more often. We can only sleep 2 hours a day because our huge bodies require so much food because we eat grass. Hello. Like we just need to be eating all the time. Yeah, carnivores sleep a lot more because they don't need to spend as much time finding and consuming food.
So while the bat exists to sleep, the that elephant exists to chew grass, basically. I mean, that's
right. It exists to kill grass. No sleep for the wicked, for the grass eaters.
No sleep for the grass eaters.
Horses, cows, elephants, they just don't have time to sleep.
Salvador Dali is another example. He also had this big aversion to sleep because, of course, he existed to paint weird stuff.
Yeah.
And maybe his aversion to sleep helped him because he had a technique about a 1 second micro sleep. He would sort of sit upright holding a key with an upturned plate beneath. And as soon as he dozed off, the key would hit the plate and it would clang and sort of jolt him awake. And it worked, you know, well, I mean, you've seen the paintings. You can decide whether he held onto his mind.
Yeah, I mean, he produced wonderful stuff, but I feel like that would have made him so unhappy and stressed.
Yeah, I agree. Incidentally, actually, that trick of you can do it with a teaspoon. If you lay down and hold a teaspoon on above a plate and then set a timer and close your eyes, if the teaspoon as it drops and hits the plate will wake you up, and you can see how long it took you to fall asleep. In less than 5 minutes, it sort of indicates that you really should be paying more attention to your sleep more generally.
Oh, wow. That's a really good trick.
It's good, isn't it? One of the other reasons, apart from productivity and existing to eat grass, being tired, right? Being sort of deprived from sleep is really dangerous. I mean, so many car crashes are a direct result of people falling asleep, micro-sleeping at the wheel. There's some work that was done in 2020 where researchers wanted to work out exactly how dangerous it is to drive when you are sleep deprived. And they compared people who'd been awake for 24 hours to those who had consumed enough alcohol to reach the legal limit for driving, for drunk driving. And the sleep deprived people performed way worse. You're better off
Wow.
drinking. I mean, let's caveat that
You don't
heavily.
do
Don't drink.
either, but yeah.
Don't do either. But you are better off drinking than you are driving incredibly tired. There's since last year now new cars. Certainly, this is in the UK, maybe internationally, are
Yeah.
fitted with internal facing cameras in order to watch for this because it just kills so many people on the roads. But you also, I mean, to say just how painful and excruciating it is to try and just fight it without this sleep solution that we are hopefully going to have invented by the end of this episode. I mean, sleep has been used as a form of torture in the 16th and 17th centuries in Europe, but particularly in Scotland and England. The inquisitors who were looking for witches or whatever it might be, they realized that if you use physical torture, then actually it can harden people to speaking to you, harden people against talking to you. It sort of makes people into martyrs, makes them hold out longer. Whereas...
Yeah, it sounds like they need some enhanced interrogation techniques.
Exactly.
W. Bush style.
Right. That's what we're talking about here. And they noticed that if they kept a suspected witch awake for days, then, by forcing them to walk endlessly or maybe waiting till they go to sleep and then jabbing them, then inevitably it produces this confession just because our drive to sleep is so intense.
It's so intense.
But also, double bonus, lose sleep for long enough, it starts to induce hallucinations, which of course interrogators then used as proof that the victim was communicating with the devil.
Exactly.
So handy.
In Abu Ghraib, they did a lot of this to captured prisoners, Islamic prisoners primarily. They would say, well, hey, let's force them to stay awake. We can use like dogs to scare them, big barking dogs. You can give them electric shocks. There's a lot of ways to keep a person up. And as it turns out, there's no way to keep someone up that isn't stressful. And in my research, I found that this is the number one problem with sleep research and trying to understand the purpose of sleep. There's just no way to deprive a person or some other kind of animal of sleep without actually just studying a stress response.
Yeah.
Even, a really gentle way of like playing with a mouse for hours and hours for days so it stays up, it still produces cortisol spikes as it just keeps waking up. And this happens with people. I mean, people can be ethically sleep deprived because they can volunteer to do it.
I mean, they can have children. Babies will do that for you.
Yes, babies will do it for you. But guess what? It doesn't just make you tired. It also makes you irritable. And separating whether the irritation is coming from a lack of sleep or the constant arousal reflex of waking yourself up is unknown. So it's really hard to know what happens when someone doesn't have any sleep, and that's the only variable that's been changed.
So there are, before ethics committees got involved, and sleep deprivation now, by the way, does count as torture. The UN has, since what happened after 9/11, has changed its ruling on that and says that the deliberate destruction of sleep architecture is torture, full stop. Back in the day, before those kind of rulings, before ethics committees, there were researchers who would deliberately deprive themselves of sleep. Two in particular, this is in 1896, Patrick and Gilbert, they're called. And they managed to stay awake for 90 hours, which is just under 4 days. And they documented their own mental decline. So by hour 24, their attention span decreased. By hour 48, they were having trouble with really simple arithmetic. Yeah. And then it goes downhill very quickly. By hour 60, hallucinations are beginning. By hour 72, they can barely think straight. And then by hour 90, they describe themselves as barely human.
Yeah.
Which is an incredibly quick decline. I think I've stayed up for a bit over 48 hours. That's my longest ever, which was when I had my daughter. Maybe into the 50s, but I was really broken by the end.
Wow. Yeah, you'd be really broken. I stayed up maybe for about 40 hours in a row when I flew back from New Zealand. I did one of those, and this was just last week. I did one of those like day flights that's 12 hours long. So I just read the whole time, never slept. And then I arrive in LA and it's morning, and I had to fly from there to Colorado, and I was nodding off. on that flight, but I couldn't sleep. So I kept like jumping back up, and it made me increasingly hot and uncomfortable and really, really angry and short-tempered. Then I was like, well, what do I do? Do I just stay up until a regular time to go to sleep in the mountain time zone? And I did. But man, I was so loopy. I was like unable to judge, what was important and what wasn't. It was a bad position to be in.
The last election in the UK, I was part of the election coverage, which runs through the night. So,
what were you doing? Were you doing like the data of
yeah,
the
that's
votes coming
me.
in,
I was the
polling?
numbers girl.
The
Exactly.
numbers girl.
It was
Right.
honestly so much fun. It was so much fun with Alistair and Rory from The Rest is Politics, actually. You actually start off quite early because you're preparing all of your notes, all of your, you have to also prepare all of the when the exit polls close, you have to prepare your packages for that. You start off maybe 10 o'clock in the morning and you run through on air till the following 10 a.m.
Wow.
And it definitely comes in waves. So your tiredness, I would say once it gets to about 2 o'clock in the morning, that sort of that zone between 2 and 6 a.m. is really tough. But once you get past that, the next wave is actually okay. But it is quite entertaining to watch some of those broadcasts and to compare the image of anyone who's on TV for that long, from the moment they arrive as the program starts to the moment they leave, and just how much more disheveled they look. It's quite a thing.
Oh, I know. When I did the Minefield show, all of the interstitials were shot on the roof of a building at night. And so we had to do all night recordings for a week. So I'd have to sleep during the day. And then from like 8 p.m. until maybe 6 in the morning, we would film. And by the end of those, I would get so dizzy and so unable to focus. It was a good experience to learn like what happens to me when I haven't slept. But it's really bad. So what do we know about what's actually causing all of these negative effects?
I think the astonishing thing about this is just how quickly you see these negative effects. I mean, we're talking, these examples that we're describing are when you lose 1 night's sleep, when you lose 2 nights' sleep. The study done by Patrick and Gilbert was 90 hours. But I mean, there are some people who have pushed this further than that, right?
Well, yeah, and not voluntarily. There's, for example, a condition known as fatal insomnia. It's often called fatal familial insomnia because it is inheritable. If your parents have it, you most likely have it. It's caused by we know exactly what it's caused by, a genetic mutation of the PRNP gene, which is on chromosome 20 in position P13. And what this means is that your body produces proteins incorrectly. And over time, like over quite a while, up until your like 30s, you might not even know anything's wrong. But then suddenly you start to be unable to sleep. It's insomnia, right? Maybe you're stressed about something, maybe you're worried. But as it turns out, these incorrectly produced proteins are actually affecting your thalamus, which is a part of the brain that regulates a lot of automatic behavior, not just sleeping, but also your heart rate, your digestion. But the things that we notice first are the inability to sleep. It begins a few weeks of just not really being able to sleep, and then suddenly you can't sleep at all. Let me give you a timeline here. Fatal insomnia has 4 stages. It begins with not just worsening insomnia, but panic attacks, paranoia, and new phobias for about 4 months. And then for another 5 months after that, you start to have hallucinations and really extreme panic attacks. A hallucination means you're seeing things that aren't there. And then for about 3 months after that, you have a complete inability to sleep and you rapidly lose weight. And then over the next 6 months, you develop dementia and die.
Wow.
It all just kind of suddenly happens.
Wow. Okay, but if this is genetic, you know this is in your future. So when you're in
That's
your
right.
20s or whatever it is, you know that you don't know how long you have left, but you know this is coming.
If your parents or someone in your family was diagnosed with fatal insomnia, you may or may not have that same mutation. You're not guaranteed to, but there is a just astonishing documentary about 2 women who are sisters whose parents had this. And they each have, like a 50% chance of having it too. And the big question is, should we go get tested? We're not old enough now for the symptoms to start beginning, but they may or they may not. Do we want to know? And the documentary is very much about that debate. I think one of them decides to get tested. The other just doesn't want to know. It's incredible.
Which side would you fall on? If I could tell you for sure which day you would die, would you want to know? If I had a piece of paper with it written down, would you want to know?
Man, I don't know. I mean, I'm assuming that there's no way around it. It's like somehow or another it's going to happen. Because otherwise I'm going to get distracted by thinking, oh, well, then I will avoid it. But famously in all the like ancient stories about this kind of thing, you can never avoid it. It always happens. Like the way you try to avoid it causes it to happen, right? So let's assume that I cannot escape it. Like it's an execution basically. And I know it's coming at this very specific date. I don't think I'd want to know. Yeah, I think that would make me use my life better if I just knew that it was coming like a thief in the night. I would not be prepared. I would work harder. I would love harder. I would spend more time with people. But if I knew that it was, in 2057, I'd be like, nah, I'm going to procrastinate. I've got
time to waste. I've got time to waste.
Yeah, but if I didn't know, it could be tomorrow. So I would carpe the diem better. What about you?
I think I would not want to know. I think I'm quite comfortable with the idea of dying. Not completely comfortable. I don't think you're ever completely comfortable, but I think I am not resistant to it in the same way as I was when I was younger.
Well, when you were younger, if you don't mind, when did things change?
So so today I was at the hospital today, and it's my 5-year cancer-free. they don't give you a little badge.
But,
congratulations. But today is the day, in fact. Today is the day. So I had a quite serious run-in with cancer 5 years ago. And that was the switch. I think when you are really staring down your own mortality, I think it does change your view of death. And I like to think that I would be much more sanguine about it. But at the same time, I think it's different to say it is a theoretical question, would you want to know? But the reason why I said a piece of paper is because I think if it were literally in front of me, if the piece of paper were literally there, I would struggle to resist turning it over. And I think that your DNA is that version of that. It is written, particularly in this example of something like fatal familial insomnia. It really is written your future. And I would find that difficult not to turn over the piece of paper.
Difficult not to look at. Have you read When Breath Becomes Air?
Yes, it's beautiful.
It's beautiful. I very much recommend that to those listening who aren't familiar with it. It's about a brain surgeon who is diagnosed with lung cancer. And he starts writing a book about kind of just figuring out what am I? Or rather, what will I have been once I'm gone? And I love that title, When Breath Becomes Air. When does that happen? When is my breath just back to the universe? For me, and again, this is not really about sleep anymore, but I think everything's about sleep in a way, and the rest is science. But the point is, for me, I haven't had any direct confrontation with my own mortality, but I've had the indirect kind where when my daughter was born, I started to be like, oh, wait a second, all the boxes are checked. I graduated college, got married, had a kid. The next one is die. And that gave me a real existential crisis for a few years where I really struggled as I went to bed. And for some reason, I'm not as scared now. I don't know. I think brain chemistry changes as you grow up. Who knows? But
I think you also just get used to the idea a bit more. I do think that there is something about that, about just getting used to the idea.
That's right. You get used to it. You spend enough sleepless nights worrying about your own mortality, and eventually you get bored of it and you move on and you go play some backgammon or something and you have a fun time,
Go back to eating some more grass. Okay, so here's the thing though, right? We can't change when we're going to die, but maybe we can change how much life we have between now and then, because I'm still on this mission to find out what can prevent us from needing to sleep. And after the break, when we come back, I think we're going to talk about what sleeplessness does to the body and why we need sleep. And maybe that'll give us a clue as to why we have not yet found a way to solve the sleep problem.
Yeah, we'll solve sleep and then we can solve death.
Sure. Easy peasy.
All right, so welcome back. We're going to talk about what more specifically is going on that causes all these terrible symptoms from
Yeah.
sleep deprivation. What is sleep doing for us, or at least what happens while we sleep that is so important?
Okay, so I've got a couple of things here. They are based on experiments that have been done with animals that actually give us, I think, some very important clues, even though the experiments themselves are not very nice. So just as a little bit of a heads up that these are not the nicest of experiments. So back in the 80s, there was a famous researcher called Rechtschaffen. This is in Chicago. And he wanted to study the effects of extended sleep deprivation. So he had some rats. He kept them awake indefinitely. It was the same as the fatal familial insomnia. It's not just that they got sick or that they had hallucinations, that the rats ended up dying after about 15 to 20 days of sleep deprivation, this was. But the really strange thing was that up until this point, everybody believed this idea that sleep was all about the brain, that it was about clearing toxins from the brain, that it was about our cognitive shuffling, really sort of, filtering through the experiences of the day and making your brain more efficient. But when they performed these autopsies, what was bizarre was that, they were expecting the rats' brains to be total mush, really. After this time. But the brains were structurally fine. So, in fact, no major organs had this kind of definitive anatomical cause of death associated with them. All that had happened was in advance that the rats had eaten twice as much food but lost loads of weight, as you described with the FFI.
Yep.
Fatal familial insomnia. They also lost their ability to regulate their body temperature. They've got very strange, like skin lesions, and then they just died of this catastrophic system failure. But it was all this really strange mystery that people knew that too much sleep deprivation, or not enough sleep rather, would kill you, but no one really understood the mechanism. And then only very, very recently, this is 2020, there was a neuroscientist from Harvard who decided to look at this problem without assuming that the brain was the culprit of the death. So their team, they got fruit flies and they had mice, and they kept them up for days and days on end, and they systematically scanned every tissue in the bodies of the animals as this was going on, looking for cellular damage. And they found the smoking gun. They found what was causing the problem. And it wasn't in the nervous system. It was in the intestines, which is so strange. Like, why would it be that it would be your digestive system that would cause this problem? And it turns out when you deprive an animal of sleep, their gut fills up with these toxic levels of something called reactive oxygen species, or ROS. And these are these unbelievably reactive molecules that you actually find naturally during metabolism. They're kind of produced naturally. And at normal levels, they're fine. Your body can handle them. But when you stop the animals from sleeping, this ROS in their small and large intestines builds up, and causes this massive oxidative stress, which is essentially, it's like rust, but the biological version, really. And all of this excess ROS, it started shredding the DNA, shredding the fats, the proteins inside the gut, which explains the weight loss despite the additional eating. So, this wasn't brain failure. They died because their intestines were being biologically incinerated from the inside by these toxic molecules.
Do we know what causes or what connection there is between lack of sleep and the ROS elevation?
Yeah, so that was in 2020, and that was still the big question, exactly as you've described. So in November 2023, so this is like less than 3 years ago. This was a study published in Cell, it's a very prestigious journal from Peking University, and it looks like we've finally worked out what was going on. So they had some mice that were kept awake almost continuously, so 96% of the time. And mice normally sleep, it was 50-50, wasn't it?
Half the time, yeah.
And sadly, 80% of these mice died, 20% of them survived. So as these mice are kept awake, the brain is like frantically producing this sleep promoting molecule. It's called progranulin D2 or PGD2. Sort of sounds like a robot from Star Wars. Anyway, normally this PGD2, it builds up, you get sleepy, you fall asleep, and then the brain clears it out. You're fine, it's done. But because you force these mice to stay awake, the brain ends up pumping out so much of this molecule that the system starts overflowing.
Huh.
It breaches the containment, it physically leaks across the blood-brain barrier, spills out into the body's main circulatory system. And then what happens is the immune system detects this flood of this molecule all over the place and is like, whoa, emergency. This is like a catastrophic situation, triggers this gigantic immune response, specifically called a cytokine storm, which you may remember from COVID, which was the thing that really caused problems with COVID. So all of these white blood cells, they swarm the tissue. The body is just flooded with these inflammatory signals. The immune system goes into this blind rage. And, we think that is what has triggered that fatal explosion of ROS in the gut, the rust, essentially, that the Harvard team found.
Wow. So is this part of that glymphatic system I've been reading about, the system of toxins or just chemicals, let's say in general, that build up during waking hours that then need to be flushed and can seemingly only be flushed during a sleep cycle?
Exactly. Exactly right. Exactly right. PGD2 is precisely one of those. Just to be sure that the PGD2 was the thing that was causing all of this, the researchers then ran the experiment, but where they blocked the PGD2 pathway. Okay, so they stopped it from affecting the mice, either genetically or by literally removing the receptor or with drugs. And they found that these sleep-deprived mice still didn't sleep because they were preventing them from sleeping, but they didn't die. They didn't get the inflammation and they lived. So this is, I think, a very big clue that in mice, at least, this particular molecule is a key part of what is causing this attack of the body on itself. But I think crucially, what's interesting here is that death by sleep deprivation, nothing to do with the brain, despite your brain feeling the effects of it. It's actually death by friendly fire. It's your own immune system that ends up burning your organs to the ground.
So does this mean that there could be a path? Maybe it'll take a long time, but in the future, for us to figure out ways to counteract all of these problems. We can say, look, normally sleep fixes this, but we found a medicine that does it faster while you're awake, and slowly we whittle away at the amount of sleep we need.
You can just flush out the PGD2 and you're done.
Yeah, flush it out.
That would be nice.
Rather than taking 8 hours to do it, can we do it in like 10 minutes? Like a bathroom break, but it's a brain flush break.
I mean, I think it's going to be a bit more complicated than that, unfortunately. And the reason why I think it's a bit more complicated than that is because time is literally built into all of the cells in our body. This isn't a preference, it's this coordinated thing. This is some work by Russell Foster, a very good friend of mine, and he's written this amazing book on sleep, by the way, called Lifetime. It's just fantastic. And one of the ways I think to describe it is that every cell in your body, every single cell in your body has this process in it. You can kind of imagine it like a protein factory. So when you wake up, there's a couple of genes in your DNA that turn on and start manufacturing this specific protein. And during the day, these proteins, they pile up inside your cell. And the pile, I mean, you can sort of imagine the piles gets higher and higher and higher. And after 12 hours, the pile of proteins is so massive that it physically blocks the factory doors. So the genes can't make it anymore. So the factory shuts down. And then during the night shift, over the next 12 hours, you get the reverse process. That pile of proteins breaks down slowly and dissolves. And right around the 24-hour mark, the proteins are gone and the process starts all over again. So this is one of the reasons why jet lag is so painful, because you have this cell time. It's these cellular clocks in all of the cells in your body, but your brain is sort of like the master conductor that is trying to synchronize everything all together. Because all of these cells have their own clocks, because every organ also has its own clock. Your stomach knows when it's time to digest, your liver knows when it's time to process sugar. They need this conductor to keep them in sync. Otherwise, you'll be biological chaos. And the conductor is called the suprachiasmatic nucleus, which is this little cluster of neurons that's sitting right above your optic nerve, takes in light from the sun, acts like the atomic clock for the rest of your body. And what happens with jet lag is that it's not just that you're tired. It's not just that you're tired from traveling. It's that the clock in your brain has shifted because it's doing that based on light. But the clocks in your liver and your kidneys and your stomach, they're still operating on yesterday's time. You've got this temporal desynchronization. Basically, they're completely out of rhythm with one another. So I don't know. I think that I don't think it's going to be quite as simple as just putting in a drug that blocks this one particular protein of PGD2. I think you're going to have to worry about all of the other little clocks that are going on in your body.
That's right. Yeah. Like it sounds like there's a constellation of probably 100 different things that sleep is helping us do that would have to be replaced with new medical procedures or drugs. And ultimately, as I've surfed around and asked people about like curing sleep, another thing they mention is that they wouldn't want it done away with because they like it. It is so pleasurable at the end of a hard or a long day to rest. It is so comfortable to wake up and see that you have another couple hours before you have to be up and to get to sleep more. It's not like smallpox where everyone's like, get rid of it, I don't care. It's like, I don't know, I kind of like it. I mean, yeah, I'd be more productive, but do I want to be more productive?
Maybe there's only so much grass you can eat.
I mean, humans actually sleep a lot less than you would expect, apparently. There's a great study I was reading this morning that looked at how long should humans sleep. We're a primate. We're a kind of primate. So let's compare ourselves to gorillas and bonobos and chimpanzees. And looking at all the different measures that there are, like an alien scientist would expect a human to sleep for something like, actually, I've got the numbers right here, 10.3 hours. That's where we should fall. But humans don't sleep that long. And it's not just because of televisions and smartphones and electric lights. In the ethnographic research that looks at people who have no electricity, I'm talking about people like the traditional Malagay on Madagascar. They sleep about 6.5 hours a night. Not the 8 that we often talk about. I need my solid 8. Well, the Hadza hunter-gatherers, 6.2 hours per night. There are 3 other hunter-gatherers that were quoted about 6.5 hours. Haitian non-electric sleepers, meaning they don't have any electricity, nothing to keep them up, 7 hours. And so like Western populations are also around 7, but it does not seem like modern life has caused sleep amount to go down. Our relationship to it and the quality of that sleep might be different. Our sleep hygiene might be worse, but it doesn't seem like a human, like a paleo human, slept a lot.
I do sort of wonder about this though, that it is a bit, it kind of goes back to what you were saying right at the beginning. The idea that evolution would select for something that left you so vulnerable, it is weird. I mean, what are the theories about that?
Okay, so here's the thing. Obviously, you can talk about sleep as a vulnerability. At the same time, you can think of it mathematically and you can say, well, what's better for reproductive success? Me being at the same energy and focus level every hour of the day for 24 hours? Or if I sacrifice some focus and ability some of the time, and I reserve that for like a short period of activity, maybe I can be stronger and faster and smarter than my conspecifics and my predators, than my threats. Now that works if you can safely have lower activity and awareness levels so you can store up. And if you live in the trees, like you're a chimpanzee, it's pretty easy. But Homo sapiens came down from the trees for some reason. Okay, our species did not live in the trees. We sleep on the ground. And that opens you up to being a lot more vulnerable when you sleep. And so that's one of the hypotheses the researchers have for why Homo sapiens sleep so much less than predicted. Another one is that we are so social. And our lives depend so much on trading stories and skills. Sleep is an opportunity cost in that case. If I'm sleeping, I'm not sharing and teaching skills to others. I'm not being social. I'm not forming relationships. In some weird ways, it feels like sleep isn't necessarily that human of a thing. And the reason I'm even saying this is that when I went into this episode, I thought, you know what? I bet REM sleep, especially like dreams, they're so abstract and metaphorical. Surely human creativity and imagination is like somehow interlinked to our REM sleeping. Like maybe that's what sleep is about. It's about consolidating memories, which it kind of is, but there must be a connection between what makes us characteristically human and our sleeping. But it does not feel that way. It feels almost like we've had to give up some sleep to become human. But then you might think maybe it's the kind of sleep, because sleep has these two forms. You've got the non-REM sleep and the REM sleep. REM stands for rapid eye movement. During a rapid eye movement phase in your sleep, which you have multiple through a night, your eyes rapidly move and your brain is very much awake. Its activity levels are really high. During the rest of your sleep, it's really low. And it's during REM cycles that your dreams occur. My first thought was humans must have way more REM sleep than anything else, but that's not true either. We sleep 7 hours a night, and we get about 2 of those 7 are in a REM cycle. The platypus sleeps about 14 hours a day, so twice as much as we do, but gets 4 times as much REM sleep, 8 hours a night.
I mean, are you surprised the platypus are having wacky dreams? I mean, are you?
I know. They're a wacky animal, but you can look this up. Other non-wacky animals are the same. They might sleep more than us, but they have a disproportionately large amount of REM sleep. And none of these animals are out there writing books about differential topology or building rockets or debating justice. Like trying
to categorize platypi.
Or they're not worrying about is it platypuses or platypi, but we are. So I don't think the REM sleep has anything to do with it. And then beyond that, you don't necessarily seem to even need REM sleep. A lot of medications remove REM sleep from a person's life. And this can happen for years and they have no cognitive decline. They don't seem to be any different. In fact, I read a paper that argued that REM sleep might be more about thermoregulation than any deeper, creative, or emotional reason. That basically the brain has to cool down. It needs to have something has to happen to the cells in the brain, perhaps, in order for them to not get stuck and hallucinate. But if it slows down too much for too long, it literally gets too cold and it's not ready to be rapidly awoken in the case of an emergency, a predator, a problem, a natural disaster. And so periodically, during our sleep every night, it has to warm itself back up. And that's all REM sleep is. It's just warming the brain back up.
That's amazing.
And it works really well because our muscle tone is so diminished when we sleep that the brain can go and our eyes go crazy and we dream, but yet we don't move. So we don't hurt ourselves, we don't hurt other people, but it needs to warm itself up. And then it's warm enough and we go back into that slow wave sleep where we're very much not there. But then, I got to warm up again. So that blew my mind because I had always lived my life thinking that REM sleep was this important thing that was key to consciousness and the human condition. And it just might not be. But I want to caveat all of this by saying that all these things, we're learning this stuff now. This is new. A lot of this is new research.
Yeah, this is proper cutting edge.
Yeah, we're finding that sleep is not the same as a virus. It's not like, kill the virus, problem solved. Sleep is 1,000 different viruses that are all necessary. And so we just have to live with it. We just have to take a nap.
Take a nap, exactly.
So in the paper, I loved this. They said that REM sleep might just be the brain's way of shivering. Periodically, it has to warm itself up. But we think that it's oh my gosh, the dreams told me something about the future or my relationship with my mother. And you know what? Maybe they weren't trying to, but maybe if it makes you think about that relationship or that, interview you have tomorrow, it can lead to insights. I'm totally pro dream. Don't paint me as an anti-dream guy. But if that's not the advantage of sleeping, what is? If we go really far back, and we look at even single-celled organisms, there can be rhythms, temporal rhythms can be found in them too. And so my favorite argument here is that sleep may have began because if you are a life form on Earth, you've got to find a niche, okay? And you want to exploit that niche and thrive in it. But you cannot find a single niche on this darned planet because it's spinning. We have night and day. So even if you're a little orchid that needs to live only within this 5-meter radius or you'll die, you still have night and day. And so here's the deal. How about during one of those cycles, I just turn off? I turn off so that I don't have to be fit during that period. I don't have evolutionary pressures for living in the day and the night. And so if that was the beginning of sleep, then it could have been co-opted by later organisms in the history of evolution for doing things like cleaning out neurons, for cleaning out and consolidating and defragging memories. And that seems to be what we use it for.
That's absolutely fascinating. I like that idea also because when you look at marine animals, I'm thinking about dolphins here, for example. Dolphins, whales, sharks, they don't have the same relationship with sleep that we do. There's not this sort of transition for the nighttime. It's like dolphins, for example, can sleep with half of their brain at a time.
They kind of have to.
Sleeps. Yeah.
They can't just turn off the way we can and stop evolving, stop having threats. They still need to clean out the brain or whatever they're doing. But yeah, they have to just put one half of their brain asleep at a time, keep the other half ready so that they stay alive. So what I love about the theory is that it's kind of like maybe sleep began not because there was nothing to do in the night, but so that we wouldn't fall in love with the night. So we wouldn't become this creature that had to expend energy being fit all the time.
Your take on things, Michael, never ceases to amuse and amaze me. Why would we be unconscious though?
I know,
sure,
right?
I accept this idea. I like this idea of there being the adaptation towards a particular environment rather than two simultaneously. I like that a lot. But I don't know why it would cause unconsciousness. You can rest, you can rest in front of the TV. You can rest while reading a book. Why it just sort of feels a bit wild that you would add that in.
I know. Does it have to be that way? Does sleep have to involve me, myself, my consciousness completely checking out for a while? On the one hand, it feels like, well, if it must, then maybe it's because there's also some evolutionary pressures on consciousness, on the way I think. Do I think differently at night, though? It's also been shown that the memory problems caused by sleep deprivation can be somewhat alleviated by simply resting. Just sit quietly in a chair and don't take in any more information. Your brain is still trying to consolidate short-term into long-term memories, and you perform better at memory tasks. So, that is some good news, by the way, if you struggle sometimes to sleep and you're just laying in bed and you're not asleep and it's making you more and more anxious. The Mythbusters even showed this. It's fine.
You're still resting. Yeah.
You're still resting.
And you're still doing a lot of the good stuff.
If you're just laying there in the dark, that's still better than getting up.
I think you can also end up dreaming about sleeping. It's actually quite hard to know precisely, unless you're sort of, using a sleep tracker, which generally, if you are struggling to sleep, I wouldn't. It just makes you more anxious.
Exactly. Just let your body do its thing. You're just along for the ride.
And maybe we should say, we've spoken a little bit about proteins. We've spoken a little bit about cell time and the various the sort of oxidation that happens in the gut. But I think it's also important to say the profound impact that sleep does have on the brain, or rest at least. Your synapses are pruned and recalibrated. Your memories are consolidated, which can happen when you rest. Your metabolic waste is cleared via lymphatic flow, which you were describing earlier. Your immune signaling is regulated. Your cellular stress responses are resolved. Your circadian gene expression cycles are coordinated. There's an unbelievable amount of stuff that is happening. And if we are looking for a cure, if we're looking to solve this, I think there's going to be a long time coming. There's quite a lot of complex stuff going on there.
Yeah, there is. That basically answers the question of why we haven't cured sleep yet, why we still need it, why we still need it to function properly. On that note, I was just watching a video this morning from University of California Television. Charles Nunn at Duke University gave a talk about a paper that he worked on where he talked about that glymphatic system, all of this mental brain neural stuff that is that's basically cleaned out of toxins while we sleep. And I guess whatever mechanism is responsible for our sentient awareness, just has to be off for that cleaning to happen. For a long time, we never saw Alzheimer's in other animals. A lot of that is changing, but it's still an open question to what extent the cognitive decline that humans see later in life, but also humans sleep a lot less than we predict that they should. So the trade-off for being more social and more productive may be that our brains don't get cleaned through our lifetimes enough. And then you wind up with all these things, especially amyloid beta, which is part of the process that we think leads to Alzheimer's disease. However, I want to also point out that studies have not shown that sleeping longer is good. In fact, if people sleep a lot more or a lot less than 7 hours a night, bad longevity, bad health.
Right. But then I wonder how much of that is about the lifestyle that's associated with sleeping too much or too little.
Exactly, right? If you're sleeping a lot, it's probably not because you've chosen to.
Yeah.
It could be that there's a lot of other stuff going on in your life that's making you stay in bed, and vice versa. If you're not sleeping a lot, there's probably a lot of stressors in your life.
But then this idea that Alzheimer's, which, is at least in part down to a buildup of this particular protein, is this disease of complex intelligence and sleep failure and extreme aging all at once.
Yeah.
Yeah, when the sort of nightly wash cycle can't keep pace.
Yeah, and that wash cycle is not simple. It's not compared to digestion, it is so much more complicated that we still don't understand how it all works. And all we know is that sleep is doing something very, very complicated and very, very important.
So I guess then our big conclusion is have fun with your 52 years of being awake, because that's all you're getting.
That's all isn't that wild? I can say, here's how much time I have left in my life, but then I gotta subtract a third of it because unless I take an attitude of, but sleeping is something I love doing, I'm glad that I get to spend a third of my remaining years on earth asleep.
Yeah. It's just, I like going to sleep a lot. I like the feeling of having slept a lot. There's definitely sometimes where it feels like a very big waste of time for me.
Yeah, I never have disliked sleep. I get sleepy pretty early. I'd say by 10 p.m., I'm like, all right, I'm done. But I wake up really early and I love waking up early, not feeling tired. I don't use an alarm clock. And then I just am able to work and read. I'm finally reading The Lord of the Rings. Look at this tome. This is not just a book. This is a finger workout. Try to read this in bed. You can't fall asleep. It's going to fall in your eyeball and cut it out. This is... And look how far through it I am. There's my little bookmark ribbon. I'm
You've
just
probably
on
done
chapter
150 pages already. Wait, what time do you wake up in the morning then?
I usually wake up around 4:50 or 5, but I go to bed at 10. So how many hours is that? That's 7,
6.5.
right?
Ish.
6.5. I'm fine. Yeah, I'm feeling fine.
I think Michael, you should do your own version of, I wake up at 4:30. The first thing I do is I do a finger workout. Then I, like the bros.
I know. I see. That's why I don't really talk about this too much, because
By 6 a.m., I've had a whole work day.
I think that I hate that kind of stuff. The like, I
Yeah.
wake up at 3 and then I journal and then I work out. And I'm like, no, I wake up and I read The Lord of the Rings and I drink vanilla Coke and I browse Reddit. I mean, I need an intake phase in my life, and then later on, when everyone else is up, I can output.
So there we go. I think that's our big conclusion. Elephants were born to eat grass. Bats were born to sleep. Michael was born to browse Reddit.
Well, I want to say I also heard something really, really cool from Charles Nunn's talk. We can link that down in the description as well. He was like, a lot of the studies we do on human sleep and animal sleep, we hope to learn a lot about improving human health from these studies. But we have to keep in mind that animals and people who are from cultures that don't have electric devices, I mean, they're not necessarily sleeping in a way that evolution prepared for them so that they are healthier. Evolution and natural selection operates on reproductive success, not health and longevity. And so we have a lot still to learn about what kind of sleep is healthy. What's natural, paleo sleep schedules might not actually be the thing that gives you the best life. It's what means that your descendants survive, and there's a lot of them.
But wait, hang on. Explain what you mean by that.
What I mean is, the more we learn about how humans should be sleeping, the more we have to answer the question, what does should mean? Mm-hmm. Does it mean what sleep does for us? Does it mean how we would sleep if there were no distractions? Does it mean what feels good? Does it mean what allows us to be more productive? We don't know. And by studying the history of sleep in medieval times, there's a lot of talk about people sleeping twice, having 2 sleeps in the night.
And then waking up for food in the middle.
I had my first sleep, woke up at about 3, did some work, and then had my second sleep. Is that healthier? Or is the way, Neanderthals slept, or prehistoric people slept, or people from tribal cultures with no phones or electric lights, are those healthier ways of sleeping, or are they ways that just led to better reproductive success?
What I'm hearing from you, Michael, is that after all this time, it might be that Salvador Dali was correct. Maybe the best way to sleep of all is with a key and a plate in your hand. And on that note, it's quite late here in the UK. I'm going to go to bed.
You better. Yeah. Yeah. Cleanse your brain, cleanse your gut.
I will.
Sleep it off.
So sorry, everybody who was hoping for a miracle cure. You're going to be sadly disappointed.
I won't lose any sleep over it. It's a hard problem, guys. We're not even close to solving it. So for now, enjoy your rest.
Well, that's all for today. Join us on Thursday for our episode of Field Notes, and again on Tuesday for our main episode.
And if you'd like to ask us a question, which we may answer on an episode of Field Notes, send your questions to therestiscience@goalhanger.com. The rest, resting is a mystery. The rest is science. The rest is necessary. There's something there. The editors can turn that into some brilliant, like philosophical thought and promo for the show.
Send us your ideas.
Send us your ideas.
Until then, good night.
Good night.